This lesson has been developed in the framework of SCILED project. Module 2, Footwear Sustainability. Unit 4. Product Lifecycle Management Approach for Sustainability.
Lecture 4.2. Footwear Product Development Strategies to Support Sustainability.
This lesson is structured as following. Definitions. Introduction to Eco-Design. Eco-design strategies including design, materials, production, distribution, use and end of life.
Definitions.
Environmental aspect may be defined as an element of an organization's activities or products or services that interacts or can interact with the environment, according to ISO 14001-2015.
Environmental impact is any change to the environment, whether adverse or beneficial, that wholly or partially results from an organization's activities, products or services, according to EMAS.
Life cycle may be defined as consecutive and interlinked stages of a product system, from raw material acquisition or generation from natural resources to final disposal, according to ISO 14040-2006.
Life cycle assessment involves the compilation and evaluation of the inputs, outputs and the potential environmental impacts of a product system throughout its life cycle, according to ISO 14040-2006. Introduction.
Climate change and sustainability are the topics of the day. The climate change is a real problem that affects the worldwide population and needs to be faced, and urgent actions are needed in order to save planet lives. Nowadays, these topics are increasingly discussed among political and scientific communities, but also among the civil society. The 21st century consumers are more well-informed and concerned with these issues and are demanding for more sustainable products and information. The footwear industry is conscious and prone to integrate the aspects related with the environmental sustainability and circular economy in the development of new footwear concepts and production processes. The development of truly environmentally sustainable footwear products begins with a design process that should be based on life cycle thinking. At this stage, it is fundamental to define the shoe concept and consider the entire footwear value chain, from the selection of raw materials to product's end of life.
Eco-design is the design process of a product or service in which the environmental factor is considered. Eco-design can be defined as the integration of environmental aspects into product design and development, with the aim of reducing adverse environmental impacts throughout the product's life cycle, and should be applied at an early stage in the product development phase, leading to improved design specifications. The aim is to develop new sustainable products, minimizing the environmental impact throughout the product's life cycle, without compromise performance, functionality, quality, safety, ergonomics and cost. It is necessary to find the right balance to develop footwear products that fulfill the environmental requirements, the company business and consumer expectations.
Currently, there are available several methods and tools to support the implementation of eco-design, less or more complex in its implementation, including MET matrix, checklists, strategy lists, eco-indicators, carbon footprint, 10 golden rules, LCA, among others. The most suitable tool should be selected according to the type of product, stage of the product development process, objectives of company and development team and resources allocated. In this lecture are presented strategies, based on the work done on Life Green Shoes for All project, to assist students and footwear companies in the integration of eco-design and the development of footwear products aiming a lower environmental footprint.
The implementation of eco-design may include several potential benefits in different dimensions, namely, economic benefits by optimizing the use of materials and energy, processes efficiency and reducing the waste production and disposal, promotion of innovation and creativity, identification of new product concepts and new business models, improve the image of company and/or brand, enhancement of employee motivation, reduction of environmental and human risks, compliance with environmental legal requirements.
The implementation of eco-design process in a company requires the involvement of top management, ensuring that the new footwear concepts are integrated in the strategy and fulfill the environmental and business objectives of the company. Eco-design involves the knowledge and competencies of several disciplines and requires a multidisciplinary team and departments that covers the whole shoe development process, such as designers, product engineers, material specialists, purchasing department, for example materials, components, chemical products, etc. Environment, quality, Marketing and sales. ISO 14006-2011 divides the eco-design process into 6 steps, namely: specify of product's function, define environmental objectives, improvement of environmental strategies for the product, based on the defined objectives, develop environmental objectives based on improvement strategies, establish a product specification addressing the environmental objectives, develop technical solutions to meet the environmental objectives.
Eco-design strategies.
There are multiple eco-design strategies including 1. Design for function addressing product functional optimization, multiple functions or modularity.
2. Design for durability and reparability targeting product longevity, reparability and maintenance or environmental improvements due to new technologies.
3. Design for recycling, reuse and recovery, namely, considering easy disassembly and subassemblies, reduce the material and product complexity, or increase the amount of recycled and recyclable materials. There are multiple eco-design strategies regarding the materials including 1. Select low-impact material, namely renewable materials, recycled and or recyclable materials, biodegradable materials or materials that involve less energy consumption. 2. Reduce the use of materials, for example reduce the weight, reduce the volume and reduce the variety of materials in the same product. 3. Avoid potentially hazardous substances and materials by acting proactively and analysis documents to check human health and safety, environmental aspects and impact of materials during their life cycle including in transportation. Materials practical suggestion for applications in footwear industry include:
select certified material with lower environmental impact. Create a database of certified materials and suppliers.
Use natural, renewable, bio-based recycled, recyclable and biodegradable materials, for example, leathers, cork, wood, recycled and recyclable biopolymers, among others. Select as few different materials as possible for the same footwear, thus facilitating subsequent recycling.
Select materials in compliance with REACH legislation or other applicable legislation. Avoid materials that affect the ozone layer, such as fluorinated gases.
There are general eco-design strategies regarding production, namely: reduce the stages of the production process, use clean production technologies, minimize energy consumption, use renewable energy sources, avoid the use of hazardous consumables and auxiliary materials and minimize waste production. Practical applications in footwear industry include: cleaner production techniques, for example, changing cabins finished from water curtain to dry filter finishing cabins. Processes that make the use of materials more efficient, for example, computer-controlled cutting machines. Study the possibility of combining the essential functions in a single component in order to require less production processes. Use materials that do not need additional treatments, for example, surface treatments to certain soles prior to bonding. Raise awareness among workers about energy consumption so that production processes are more efficient and about the advantages of reducing waste generated during production. Reduce the use of fossil fuels and increase the use of renewable energy. Designing the product minimizing the waste of materials, and recycle, reuse sub-products in the company itself.
More environmental efficient distribution techniques are fundamental to reduce the environmental footprint of footwear and include: reduce packaging volume and weight, eliminate unnecessary packaging, use reusable packaging, use recyclable packaging, more environmental efficient logistics system, more efficient transportation, namely avoid plane transportation. Practical applications in footwear industry include: use containers of standard and modular size, to maximize transport. Transportation by train or marine container is preferable to the truck, they are less polluting. The use of electric vehicles will always be preferable. Raise awareness of the sales department to work with local suppliers. This helps reduce transportation cost and generates less stock.
Strategies to reduce the environmental impact in the use phase include: use clean maintenance and repair techniques. Avoid the use of hazardous cleaning products. Create a strong product-user relationship. Practical applications in footwear industry can consider, namely: avoid designing for passing trends. This causes it to be replaced once the design has become old. Ensuring that the aesthetic life is not shorter than the technical life. Use spares parts, for example, laces, in socks, fashion accessories, that can be replaced in case of damage. Include a use guide for cleaning and maintenance of footwear, to increase its life of use. Design technically durable products. Provide added value to footwear through functionality and innovation, increasing its potential usage life. Strategies to optimize the end of life include product disassembly, labeling materials for recycling, waste recovery and valorization, recycling, biodegradability and composting, and energy recovery, consumer communication. Practical applications in footwear industry require the involvement of other stakeholders and can include, namely, information to consumer about the best alternatives at the product end of life, for example, destination of post-consumer shoes. Promote and collaborate on the creation of a platform for waste management of footwear products at the end of life. Promote and collaborate on the creation of footwear collection points for recycling. Promote the return of used shoes by the consumers.
Examples.
Lemon Jelly is a Portuguese brand with local manufacturing in Portugal which produces sustainable footwear. 72% of their production waste is recycled. The manufacturing unit has installed 900 solar panels, allowing them to operate with 100% renewable electrical energy. And in 2019 they launched a collection of boots made of 100% recycled waste. Bolflex is a Portuguese sole manufacturer that has been working to reduce its environmental carbon footprint. The company follow a practice with 3 key words crucial for a better environment: reduce, reuse and recycle. They launched 2 sustainable products, an eco-friendly sole, based on natural products, hence its deterioration shall not pollute the environment, and a recycled sole, produced with 70% of recycled rubber. Adidas Group, which owns Adidas and Reebok, aims to use 100% of recycled polyester in their products by 2024. The company aims to reduce the greenhouse gas emissions from both their own activities and those of their suppliers by 30% by 2030 when compared to 2017. They also aim to create 15 to 20 million pairs of ocean plastic in 2020, up from 11 million on 2019, 5 million on 2018 and 1 million in 2017, and adopted the circular business model, which includes minimizing resources, waste and emissions to reduce the environmental carbon footprint. Nike has been also working towards sustainability. These are some of the innovative solutions and materials. Nike Flyknit is a footwear upper resulting in an average of 60% less waste than traditional footwear upper. In the fabrication of Flyknit, 31 million water bottles were diverted from landfills in 2019. Nike Flyleather is made with at least 50% recycled leather fiber and has a smaller carbon footprint than traditional leather manufacturing. Flyleather also improves cutting efficiency and creates less waste than traditional cut and sew methods for full-grain leather. Nike Air soles designed since 1994 contain at least 50% recycled manufacturing waste and since 2008 have been made with 100% renewable energy at their Air facilities. The company reused more than 90% of the waste from materials used for Air soles to make new, innovative cushioning systems. Since 2010, Nike has diverted more than 7 billion plastic bottles from landfills. Their recycled polyester is made from plastic bottles, pre-consumer textile scraps, and post-consumer garments. Since 2010, we've been on a drive toward 100% sustainable cotton. Certified Organic, Recycled, and Better Cotton Initiative, BCI, are 3 ways that we are pushing sustainability in our materials. Combining recycled polyester and organic cotton creates a performance material that reduces carbon emissions and uses less water and chemicals than virgin polyester blends with conventionally grown cotton.